students. I'm Shahrzad. I'm your TA today.
I will be taking you through a video lab for doing the experiment of substitution nucleophilic reaction. I have already drawn a scheme on the board for you. You can see a table on the top of the board. You need to fill out this table with any kind of data, result, and your observation from today's experiment and write it in your lab report. As you know, we have two kind of substitution nucleophilic reaction. One is SN2 reaction and the other one is SN1 reaction. In SN2 reaction, we have a 5-membered intermediate. Alkyl halide as a substrate and nucleophile both are involved in rate determining a step. For SN1 reaction, we have a carbocation as an intermediate, and just alkyl halide as a substrate is involved in the rate determining a step. For each reaction, we need 6 test tubes. In each test tubes, we need to pour our alkyl halide as a substrate. We have different kind of alkyl halides. 2 are primary, 2 secondary, and 2 tertiary. And in each group, there is 2 different leaving groups. Primary substrates prefers SN2 because of less steric hindrance. Tertiary substrates prefers SN1 because of stable carbocation. The other effective factors are nucleophile and solvents. SN1 reactions prefer weak nucleophile and polar protic solvents, but SN2 reactions prefer small and strong nucleophile and polar aprotic solvents. During today's experiment, we can study the effect of all these factors on substitution nucleophilic reaction. SN2 reactions prefer a dry medium because water is an aprotic solvent and can solvate the nucleophile and doesn't let the reaction occur. You need to watch whole parts of the video and based on that, write your lab report. Along the way, I'm going to ask you some questions. These questions will be graded, so you need to answer them and write them on your lab reports in order to get full credit.
Okay, let's go.
I want to show you the alkyl halides that we will use during this experiment. This is 1-bromobutane, which is a colorless liquid. You can see the molecular sieves on the bottom of the bottle in order to absorb water. As you can see, all other bottles also have colorless liquids. This is 1-chlorobutane, 2-bromobutane, 2-chlorobutane, 2-bromo-2-methylpropane, and 2-chloro-2-methylpropane. These 2 are primary alkyl halides, these 2 are secondary, and these 2 are tertiary alkyl halides. This is the nucleophile that we are going to use for SN2 reaction. This is a 6% solution of the sodium iodide in acetone as a solvent. I took 6 clean and dry test tubes for SN2 reaction and I labeled them all with the name of each substrate and type of reaction. This is 1-bromo, 1-chloro, which are primary, 2-bromo, and 2-chloro, which are secondary, 2-bromo-2-methyl, and 2-chloro-2-methyl, which are tertiary alkyl halides. We have to label them because when we want to put them in the water bath, Recognition of what substrate is in which tube will be hard. 6 test tubes for SN2 reaction are ready and labeled. So for the next step, I'm going to add alkyl halides to each test tubes according to the label on them. In this step, I'm going to add 0.1 ml of each alkyl halides to its related test tubes. This is a 1 ml graduated plastic pipette that I'm using to take and transfer the alkyl halides to the test tubes. This is 1 bromobutane. Up to here is 0.1 ml. I'm adding to the first test tube. I'm going to take 0.1 ml of the 1-chlorobutane and add it to the second test tube. I should add same amount of each alkyl halide to its related test tube. This is 2-bromobutane. This is 2-chlorobutane. This is 2-bromo to methylpropane. And the last one is 2-chloro to methylpropane. In next step, I'm going to add nucleophile to each test tube. The nucleophile in SN2 reaction is 6% solution of sodium iodide in acetone as a solvent. In this step, I'm going to add 1 ml of sodium iodide to each test tubes of alkyl halides. I also drew a table for alkyl halides in order to record the time in room temperature and 50 degrees centigrade. This column is related to the starting time of the reaction. After mixing nucleophile and alkyl halide, this column is related to finishing time of the reaction after getting the precipitation. You can see the clock all the time during the experiment in order to record the time by yourself. For taking and transferring 1 ml of nucleophile, I'm going to use a glass pipette and a pipette bulb. And for measuring 1 ml of nucleophile, I'm using a graduated test tube. And after measuring, I can add it into the test tubes of each alkyl halide. My first question is, what are the boiling point of each alkyl halide? Because we need to control the temperature of the water bath under those boiling points. You should write your answer in your lab report. Okay, we can start. I'm going to measure the first 1 ml of the nucleophile in order to add to the first alkyl halide. I'm adding to the 1-bromobutane. You should record this time as a starting time of the reaction. You can see the clock. We should see what will happen. As you can see, it starts to make a cloudy solution, so you need to record the time for the end of the reaction. This is a primary alkyl halide, and what we expect from it is reacting fast and quick with a strong nucleophile through a SN2 reaction, because primary alkyl halides have low steric hindrance. Because of that, they are so proper for doing SN2 reaction. I'm going to add 1 ml of nucleophile to the next test tube of 1-chlorobutane. This is also a primary alkyl halide, but with a different leaving group. I'm adding. You need to record the time immediately, because chlorine is not as good leaving group as bromine, so we expect that the speed of this reaction is not as fast as 1-bromobutane. Because we didn't see any immediate precipitation or any changes, we can put it away and we can check it later again. I'm going to add 1 ml of nucleophile to the third test tube of 2-bromobutane. Okay, you need to record the time immediately. In SN2 reactions, primary alkyl halides can work better than secondary, and secondary alkyl halides can work better than tertiary ones because steric hindrance is increasing respectively. I'm checking 1-chlorobutane test tube to see any possible precipitation. So because none of them has any fast reaction, I can put them in the test tube rack and I will check them later again. I'm going to add the nucleophile to the next test tube of 2-chlorobutane. You need to record the time now. I'm checking the other test tubes for any precipitation. As you can see, we have not any immediate reaction for these test tubes. So I'm going to continue of adding nucleophile to the next test tube of 2-bromo-2-methylpropane, which is a tertiary alkyl halide. Okay, you need to record the time. According to our expectation, we didn't see any precipitation immediately. But at least we need to wait 15 minutes, maximum 15 minutes for all these test tubes in room temperature. This is the last test tube of 2-chloro-2-methylpropane. I'm going to add nucleophile to it. This is also a tertiary alkyl halide. You should record the time. We didn't see any quick precipitation, so we need to put them all in the test tube rack and wait for maximum 15 minutes in room temperature. If we will not see any precipitation or any cloudy solution for other test tubes, we should put them in a water bath of 50 degrees centigrade in order to see what is the effect of increasing temperature on the speed of our reaction, if this will help the reaction to happen or not. Except 1-bromobutane, we cannot see any precipitation in other test tubes, but I want to pay your attention to the last test tube of 2-chloro-2-methylpropane. The color is changing to a pale yellow, so we can record the time here for this reaction as a final time of the reaction. But I'm going to put it in the water bath to see if this reaction can happen better and give us any cloudy solution or any real precipitation or not. I explained about the factors of substrate and leaving group on SN2 reaction. The other factors are nucleophile and the solvent. Oxygen in acetone has partial negative charge which can attract to sodium in nucleophile and help the formation of iodide as a nucleophile. Because of that, polar aprotic solvents are preferred in SN2 reactions. On the other hand, protic solvents can solvate the nucleophile and doesn't let SN2 reaction happen. Because we have a 5-membered intermediate, so a strong and a small nucleophile can works better in SN2 reactions. I want to stop recording video here, and if I see any changes, I'll be back and show you the results again. After 15 minutes, I'm back to check the test tubes for any precipitations. As you can see, a last test tube of 2-chloro-2-methylpropane is completely yellow, and this test tube is related to 1-chlorobutane is a cloudy solution. You need to record the time for the end of reaction. So for the 1-chlorobutane and 2-chloro-2-methylpropane, we record the finishing time of the reaction, but I still prefer to put them in the water bath in order to check them for any precipitation or cloudy solution. The temperature of our water bath is higher than 50 degrees, so I'm adding cold water in order to cool it down to 50 degrees centigrade. For recording the starting and ending time of the reaction in 50 degrees Celsius water bath, I'm adding 2 more columns to my table. This test tube is 1-chlorobutane. You don't need to record the time. This reaction happens in room temperature. I just put it in order to check for any real precipitation by increasing the temperature. This test tube is 2-bromobutane. Record the time, starting time of the reaction. This one is 2-chlorobutane. Record the time for this reaction too. I'm checking again 1-chlorobutane. I'm trying to regularly and occasionally check the test tubes for any precipitation. This test tube is related to 2-bromo-2-methylpropane. Record the time, please. Starting time of the reaction in 50 degrees. This test tube is related to 2-chloro-2-methylpropane. You don't need to record the time for that because this reaction happened in room temperature. I just put it more in water bath to ensure if it can give us a real precipitation or not. This is 1-chloro. It's still cloudy without any precipitation. This test tube is related to 2-bromobutane. You can see it's cloudy. You need to record the time. The ending time of the reaction for 2-bromo butane. So I'm going to put the 1-chlorobutane and 2-bromobutane in test tube rack because these two reactions are done. This test tube is related to 2-bromo-2-methylpropane. You can see the precipitation, so you need to record the ending time of the reaction for this test tube. This is a tertiary alkyl halide. We don't expect of tertiary alkyl halides to do SN2 reaction. Because of that, this precipitation shows that we have a positive error. We still have not any precipitation for 2-chlorobutane, but 2-chloro-2-methylpropane seems cloudy. This reaction has already occurred in room temperature, so you don't need to record a new time. You can explain that a higher temperature increases the progression of the reaction, so the reaction makes a cloudy and a darker yellow solution. This substrate also is a tertiary alkyl halide, so it also shows a positive error. This positive error shows that another kind of reaction happens here which caused this precipitation. And this positive error is related to elimination reactions. Always SN1 reactions compete with E1 reaction, and SN2 reactions can compete with E2 reactions. E2 reaction similar to SN2 has 2 steps, and E1 similar to SN1 has just 1 step of reaction. For the second question, I want to ask you to write the elimination equation for both tertiary alkyl halide in our experiment. We have not yet seen any precipitation for 2-chlorobutane, so we need to wait maximum 15 minutes for this reaction in 50 degrees Celsius temperature. So I'm going to stop recording the video here, and after seeing any changes, I'll be back and show you the results. After 15 minutes, I'm back to check the test tubes. As you can see, there is no cloudy solution or precipitation for 2-chlorobutane. Eventually, you can report that because of no precipitation, this substrate cannot react with nucleophile through SN2 reaction. This table shows the final results of starting and ending times for SN2 reactions. By subtracting these end and start times, you can find the time of each reaction. I took 6 clean and dry test tubes for doing SN1 reaction, and I labeled them all similar to what I did for SN2 test tubes. In this step of SN1 reaction, I poured 0.1 ml of each alkyl halide to its related test tube, similar to what I did for SN2 reaction. Draw a similar table for SN1 reaction to record the times. You have the clock over there all the time. You can record the time. After adding nucleophile to the test tubes of alkyl halides, you need to record the time as a starting time of reaction. And after getting any precipitation, you need to record the ending time of the reaction. First, we need to try the reactions in room temperature. If we cannot get any precipitation, we need to increase the temperature to 50 degrees centigrade of water bath. Let's get started of adding nucleophile to alkyl halides. In SN1 reaction, our nucleophile is 1% solution of silver nitride in ethanol as a solvent. This time for taking and transferring 1 ml of nucleophile, I'm using a 1 ml plastic pipette. Our first substrate is 1-bromobutane. I'm going to add 1 ml of nucleophile to it. Record the time immediately. It's a primary alkyl halide and it's not a good reactant for doing SN1 reaction. I can keep it in the rack and check it later again for any precipitation. I'm going to add 1 ml of nucleophile to 1-chlorobutane. Record the time immediately. The substrates which can make better and more stable carbocation can react better through SN1 reaction. Secondary alkyl halide reacts better than primary, and tertiary alkyl halide reacts better than secondary because they can make a more stable carbocation respectively. Because there is no immediate reaction, I can put this test tube in the rack and I can check it later again. Third test tube is 2-bromobutane. I'm adding nucleophile. Record the time immediately. Record the time. As you can see, the solution converted to a cloudy one, and this reaction happened under 10 seconds. This substrate is a secondary alkyl halide, and unlike primary one, it reacted quickly. This reaction is completed, so we can put it over there in the rack, and I'm adding nucleophile to 2-chlorobutane. Record the time immediately. In comparison to 2-bromobutane, this substrate didn't react immediately because chlorine is not as good leaving group as bromine. We should let it stay more time to check it again later. I'm adding 1 ml of nucleophile to 2-bromo-2-methyl propane. It's a tertiary alkyl halide, and as we expected, it could produce immediately a very nice precipitation. It also has bromine as a good leaving group. For this reaction, just write that the substrate reacted immediately and you don't need to record any time. This reaction also is completed. I can put it over there, and I'm going to add nucleophile to the last test tube of 2-chloro-2-methyl propane. It also reacted immediately. You don't need to record any time, just write it reacted immediately and made a precipitation. This reaction also is completed and we can put it over there. I'm going to check other test tubes. For 1-bromobutane, we can see precipitation. Record the time, please, for end of the reaction. This is a primary alkyl halide, which is not proper for doing SN1 reaction because primary carbocation is not stable enough. This precipitation shows a positive error, which is related again to elimination reaction. For the third question, I want to ask you to write the elimination reaction that happened here for 1-bromobutane. We have not yet seen any precipitation for 1-chlorobutane and 2-chlorobutane, so we need to let them stay more in room temperature. I'm going to stop filming and I'll be back again to show you the results. I'm back after 15 minutes. The first test tube is 1-chlorobutane and the second one is 2-chlorobutane. The second one is cloudy, so you need to record the time for the ending time of reaction. There is no any precipitation for 1-chloro, so we need to put it in the water bath. We recorded the ending time for 2-chlorobutane, but I still want to keep it in water bath in order to see a better cloudy solution or maybe any precipitation. Please record the starting time of the reaction for 1-chlorobutane. The other one is 2-chlorobutane. You don't need to worry about that. I put them both in water bath. I will check the test tubes. If I see any changes, I'll be back to show you the results. There is a more obvious cloudy solution for 2-chlorobutane. You don't need to record a new time. This reaction was completed in room temperature. Just write your observation about this reaction in water bath temperature. For 1-chlorobutane test tube, as you can see, there is no precipitation, so we need to leave it to stay more in water bath. I'll be back to show you any changes later. Please record the time for 1-chlorobutane. As you can see, the solution is cloudy. This is a primary alkyl halide because this substrate is not proper for doing SN1 reaction. It shows that there is a positive error here, which is related to the elimination reaction. You can find the final results of starting and ending times for SN1 reactions in this table. Subtract this end and start times to find the time of each reaction. This equation is related to SN2 reaction and this equation is related to SN1 reaction. For the fourth and last question, I want to ask you to complete the other side of these two equations. All the data and results that you need to report for today's experiment are in these two tables. The top one is related to SN1 and the bottom one is related to SN2 reaction. Fill out these tables, find the time of each reaction, and order them based on their reactivity.